Hi, I'm going to work through question 9 as well, and 10 in a minute. So here we've got an organic compound X, which contains just carbon, hydrogen and oxygen. And we're burning 0.43 grams of it in excess oxygen. So excess oxygen tells you that you're going to get carbon dioxide and water coming out as products. And it tells you how much carbon dioxide, 1.1 grams, and how much water, 0.45 grams. And we have to find the empirical molecular formulae. Okay, so let's write out compound X. We know that it's just got carbon, hydrogen and oxygen, but we don't know the number of atoms of each in the molecule. All right, so we know it's going to burn in excess oxygen. We don't know the molar ratio yet. And we know that we're going to make carbon dioxide and water as products. Okay, so the question tells us that that we get 1.10 grams of carbon dioxide, and it tells us that we're going to get 0.45 grams of water. Okay, as usual, we need to turn this into moles. If ever you're in doubt in chemistry, turn something into moles. Okay, so MR of carbon dioxide is 44, MR of water is 18. So these two numbers come out at 0.025 and 0.025 as well. Okay, so what we can say there is that the moles of carbon in, right, 0.025 moles, 0.025 moles of carbon dioxide is also 0.025. Because in one molecule of carbon dioxide there is one atom of carbon, so that's why we can say that. And so now that number of moles of carbon must be the number of moles of carbon in the fuel, in compound X, because the only place that this carbon can come from, right, is this carbon in the fuel. Okay, so we can then work out the mass of carbon in the 0.43 grams. Let's put the 0.43 grams up here, told to us in the question. All right, so the mass of the carbon in that 0.43 grams is is going to be our moles times our AR, which is 0.025 times 12, which comes out to be 0.3 grams. 0.30 grams. So of that 0.43 grams there, of our compound X, 0.3 grams is carbon. Okay, so now we're going to do the same sort of thing for hydrogen. So the moles of hydrogen in our 0.45 grams of water. So our moles of hydrogen in our 0.025 moles of water is 2 times that, 2 times 0.025. Just in case that's not clear straight away, if you've got 0.025 moles of water, you must have twice that, because you've got 2 atoms of hydrogen for every 1 molecule of water. Okay, so that's where this 2 comes from, and so that comes out at 0.05 grams, like so. And in the same way as we did for carbon, we're going to work out the mass of hydrogen in compound X, 0.43 grams of X, so the mass of that, using the same formula, but the AR is 1, all right, so it's going to be our 0.05 grams times our AR of 1 equals 0.05 grams. Okay, so what we know now is that this 0.43 grams of our compound X contains 0.3 grams of carbon, 0.05 grams of hydrogen, and the rest must be oxygen. So let's work out the mass of oxygen. So the mass of oxygen in our 0.43 grams equals our total mass, 0.43 grams, minus the mass of carbon minus the mass of hydrogen, and that comes out to be 0.005 grams. So we've got that many grams of oxygen, right? But again, we need to turn that grams of oxygen. Hang on a minute, that's not right. That's 0.08. Right, so let me just correct this. 0.08 grams of oxygen. Okay, so when we calculate the moles of oxygen in that fuel, compound X, all right, so we're just going to use the same old formula. That comes out at 0.005. 0.005 moles. Okay, so let's write our usual empirical formula table out. So we've got carbon, hydrogen and oxygen. We know we've got 0.025 moles of carbon. We know we've got 0.05 moles of hydrogen, and we know that we've got 0.005 moles of oxygen. But we want to turn those into whole integers, so we're going to divide by the smallest one, which is this one. So that becomes 1, but we have to do the same to each one. And like so, right? So this ratio comes out at 5, 10, and 1. Okay, so our empirical formula, all right, so therefore our empirical formula is C5H10, like so. And if we worked out the relative empirical mass, that's 5, 12s, 60, 70, 86, all right, is 86, which is pretty close to this. So I'd say the molecular formula is the same. And there you have it.